The next method is the p-value method. So the important 5 steps is almost similar to the traditional method, except for the step 3, we need to find the p-value. So the decision rule when use the p-value method is we need to compare the p-value with the alpha. If the p-value is lesser or equals to alpha, the null hypothesis is rejected. And if the p-value is greater than the alpha, then do not reject the null hypothesis. So to find the critical value for z, t, and chi-square, these are the Excel function. So the Excel function shown here is to find the p-value. Let us see example 5, z-test using p-value method. A researcher claims that the average wind speed in a certain city is 8 miles per hour. A sample of 32 days has an average wind speed of 8.2 miles per hour. The standard deviation of the population is 0.6 miles per hour. At alpha equals to 0.05, is there enough evidence to reject the claim? So to use the p-value method, first we need to highlight all the information as follows. Then we state the hypothesis like this. For h null, mu equals to 8, h1 mu unequal to 8, because we don't have any information that show the mean increase or decrease. Then we find the test value using the z-test formula, we get 1.89. Then using the z value, we need to find the p-value. So since we consider the two-tailed situation, the p-value for this z value is equals to 0.0588. So the value you can obtain using the Excel function that I shown just now. Then compare this value with the alpha. And since the p-value for z-test is greater than the alpha, then the decision is do not reject h null. And we can conclude that there is not enough evidence to reject the claim that the average wind speed is 8 miles per hour. Example 6. T-test using p-value method. A physician claims that the jogger's maximal volume oxygen uptake is greater than the average of all adults. A random sample of 15 joggers has a mean of 40.6 milliliters per kilogram and the standard deviation of 6 milliliters per kilogram. If the average of all adults is 36.7 milliliters per kilogram, is there enough evidence to support the physician's claim at alpha equals to 0.05? Then to do the t-test for this situation, all the informations are like this. Greater than 36.7, the sample 15, and the sample mean is 40.6, and then the standard deviation 6 and alpha 0.05. And then the hypothesis will be like this. H null equals mu equals to 36.7 and H1 is mu more than 36.7. Then we find the t-test value using the formula. We obtain 2.517. Then from the t-test value, we find the right-tailed p-value using the Excel formula just now, and we consider df equals to 14, then we get 0.01. And we compare this value with the alpha, and since the p-value is less than the alpha, we reject the h null. And the conclusion is there is enough evidence to support the claim that the jogger's maximal volume of oxygen uptake is greater than 36.7 ml per kilogram. And for example 7, this chi-square test using the p-value method. A researcher knows from past studies that the standard deviation of the time it takes to inspect a car is 16.8 minutes. A random sample of 24 cars is selected. The standard deviation is 12.5 minutes, and then at the alpha 0.05, can it be concluded that the standard deviation has changed? So from this example, we need to highlight all the information like this. So we have 16.8 represent the standard deviation of the population, and then has changed means we need to use unequal sign, and then we have the sample 24 and the sample standard deviation 12.5 and alpha 0.05. So this is the hypothesis, and then we find the chi-square test value using the formula. So we obtain the chi-square test value 12.733, and then using this value we need to find the p-value, and then the total p-value for chi-square 12.733 TF equals to 23, we obtain this p-value. Then we compare this one with alpha, and since it is greater than the alpha, then the decision is do not reject H null. So we can conclude that there is not enough evidence to support the claim that the standard deviation of the time it takes to inspect a car has changed. So the last section will be about the confidence intervals. So how to relate the confidence intervals in this hypothesis testing. So basically, H null is rejected if the confidence interval we compute does not contain the value of mu, which is the population or the true value of the mean. So this is the important statement so that we know that how to reject or accept H null. So let us see the example. T-test using confidence intervals. Sugar is packed in 5-pound bags, and inspectors suspect the bags may not contain 5 pounds. A random sample of 50 bags produced a mean of 4.6 pounds and a standard deviation of 0.7 pound. Is there enough evidence to conclude that the bags do not contain 5 pounds as that at alpha equals to 0.05? So we need to find the 95% confidence intervals for this situation. So to do the hypothesis testing for this type of example will be like this. Highlight all the keyword. So we have 5 pounds represent the population mean, and then the keyword do not show unequal sign, and then we have the sample 50 and 4.6 represent the sample mean, and sample standard deviation 0.7. So this is the alpha. So the hypothesis will be like this. Then using the alpha 0.05 and df 49, the critical values are positive, negative 2.01. Okay, and then we substitute the information into the confidence intervals formula for t-test. Then we get this interval. After we obtain this confidence interval, and then you compare to the null hypothesis. And since the null hypothesis, which is mu equals to 5, does not lies in this confidence interval, therefore we can say that we reject the H null, since the 95% confidence intervals do not contain the mu equals to 5. So there is enough evidence to support the claim that the bags do not weigh 5 pounds. So that's all for this chapter. Thank you.